All right, so let's talk about definition. Let's start with a foundation here. So this is a quote that I like to share from Thomas Friedman. And it really talks to the idea of weak signals. So if you have been in a maintenance organization for 30, 40 years, you have the institutional knowledge to walk into a mechanical room and hear things that might be going wrong, see things that might be going wrong, and troubleshoot things with sort of, I expect to see the damper in this position, I expect to see the valve here. And with our sequences and the way that we operate buildings becoming more and more complex as there's more data coming into us, it's coming at us more quickly, there's more change of states and more modes of operations, it gets a lot harder to have that institutional knowledge in your back pocket. It takes a lot longer to get there. And some of our new construction buildings, it can take years and years to get familiar with how they operate. And it can be really difficult to pick up on those weak signals. So that's those things that are sort of change of state within the mode that could be going wrong. And so fault detection and diagnostics is really a tool that helps to find those weak signals, that needle in the haystack, and make that just normal operation instead of I found this really cool thing once every couple weeks or couple months. So we really drive home the emphasis that FDD is truly a colleague. It enables those technicians to find weak signals together. So it's not something that will replace a technician in the field. Someone also always needs to make that decision. Someone always needs to interact with the tool and fix the problem. But it can be sort of a colleague that goes alongside you to help you troubleshoot and find those problems maybe a little bit faster. And I'll show you some examples of where that's been instrumental. So real broad brush definition of fault detection and diagnostics and how that corresponds to finding this needle in the haystack. So your building automation system, your building management system, I'll call it a BMS from now on, is what operates your HVAC system in your building and potentially your lighting system. Let's focus on just HVAC for this example. So you have lots of data that's coming in, different data points telling you temperatures, valve positions, damper positions, and all that information comes in, and you're building on your BMS then tells it what to do and will sometimes alarm if something is far out of range to the point where it needs a quick response. An example of that would be your air handling unit is discharging a very high temperature right now and it's serving, and that's all you know about it. Fault detection will give you another layer of information. So it lays on top of your building on a BMS system. It pulls in information and data from your BMS and maybe some other potential data sources such as your metering systems or your lighting systems. It pulls it all into one. And then it will also pull in historical information, the logic that's written within your building automation system. So any of those sequence of operations, your FDD system, that colleague knows that information in real time. And then it also knows the type of equipment you have. So instead of just telling you your air handler has a high discharge air temperature, it tells you the air handler has a problem that's been occurring for 3 straight days. And it's big. It's a big air handler. So it's one you might want to pay attention to. The last little D there, so when we say FDD, we're talking about fault detection and diagnostics. So that last little D there is really the really big important piece. And that takes assigns a cost to the problem. It does some engineering, and it also knows what other systems might be impacted by that. So the example here, one more level of detail would be the preheat valve is stuck open. So I actually know it's the preheat valve because I know my logic, I have some engineering, I know what type of equipment I have, and it's impacting the perimeter zones only on the 3rd floor, and it wasted $315 in 3 days. So it's really taking that extra bit of information, giving your technician even more information at their fingertips to decide whether they need to act. And then when they act, they know what to do without spending a lot of time doing the research. So how does this work? So I'm going to show you an example of, I tried to sort of anonymize it, but this is how Clockworks does it. Lots of providers do it just slightly differently, but the principles are the same here, where they take the BAS information and they pull it into some form of protocol translator. So your BAS is communicating in some sort of language, and they will have a translator that will take that language that the BAS is creating in, whether it's BACnet or whatever that protocol is, and it will translate it into something that your FDD provider can consume, and it'll transfer that data. Sometimes it's cloud-based, sometimes it's a local server, but this is a really important thing to talk to your providers about when you are looking to implement this on your campus, because it will most likely have IT implications. And sometimes facilities management and IT don't talk at the early stages of things and understand what are potential hiccups. So this is an important thing to know when you're talking to a provider, and to involve your IT on in an early phase to make sure that it's ready to go and you're not going to get any hiccups. So the next phase is the data model. We're going to use an air handler as an example. And you're going to take your BMS data, your control sequences, and your equipment schedules. And I'll give you a little bit more. I'll just give you an example with an air handler of how that works. So right here below, you have a typical AHU, right? It's 100% outside air. It's got some dampers, some coils, some fans, some temperatures. So your FDD system will take that BMS data. It'll pull in your outdoor air temperatures, any of the data that it needs to make those conclusions and those. Can you guys hear me okay?
Yes.
Okay. And then it will also, your FDD provider will input the control sequences. So what it would expect your system to do into your fault detection and diagnostics program. And so then it lives there real time, live, and it knows. The example that's given here is how your economizer works. What are your high limits, and how is it controlled? And then it'll take those equipment schedules. So how big is my fan and what's my rated flow? And that's instrumental in deciding that cost, right? It uses that to determine how much is this going to cost me to fix, and how big of a comfort impact potentially is it going to be? How big is my equipment? So it'll create this data model. And then you as a user will have an output, right? Typically, your FDD providers will be giving you this information with some key performance indicators. Some common examples are energy, comfort, and maintenance. That's something that people talk about a lot in the industry, is quantifying how big is my energy impact, how much is my comfort of my occupants impacted, and how much is this going to impact my maintenance bottom line. So they're trying to quantify these things so that you're not just given an alarm that gives you no information about, do I need to act on this or not? It just says, go do it. It's giving you a little bit more information so you can prioritize your work. And then it'll say, okay, of those, these are the top things, right? So if energy is very important to your campus, these are the top things that you should be responding to: the simultaneous heating and cooling fault, this economizer override fault, and this reset sequence. And you as an organization can kind of decide, where do my priorities lie and what should I be responding to, so that you don't get weighed down by alarm fatigue, basically, right? You want to be able to prioritize and make smart decisions about where you spend your time and how you do your work. And then finally, it'll give you a cost savings. Typically, that's energy savings at this point in the industry. I think there's a lot of conversations around where that can go outside of just energy, but at this point, that is typically where they're talking about cost savings. It's energy, but again, that's another thing to ask your provider as you're kind of interviewing folks. All right, so we're going to do a little bit of a deeper dive of the difference between an alarm and a fault. Because I get this question a lot. I had this question a lot. Iowa would talk about this frequently. And so an alarm, here's an example, right? So you have an air handler again, and your alarm, let's say, is looking for a discharge air temp that's high. So if you saw an alarm come in as a technician, it just says high discharge air temp. So when you get that alarm, you don't know when it started, how severe it is, if anything else is impacted, what is the root cause or how to fix it, right? You have to go search that out and do the investigation before you take action. If you have fault detection, you know, if you get that high discharge air temp fault, you know when it started because you have some history, right? They bring that to you. You know how severe it is because maybe you know that it serves a lab space. Maybe you have prioritized lab spaces to have a higher maintenance maintenance priority. So that would come to the top for you. You know if there are other issues present on this piece of equipment. So you know, I see a high discharge air temp, but I also see a mixed air temp sensor fault, and that I'm not utilizing free cooling. So you're putting those pieces together. You have a little bit more information, but you still need to do a little bit of investigation before you take action when you get to the root cause. Now, fault detection and diagnostics will help you get that over that finish line. So you'll say, I know when the issue started. I know how severe it is. I can even put a cost to it. I can say it's $300 per day if I let this continue. I can tell if there's other issues present on this piece of equipment and potentially other pieces of equipment. If my air handler is in fault, are my VAV boxes that are impacted by that air handler also in fault? And then it also helps to tell you the root cause. So it takes all of this information. It says, I know I have these 3 problems. These are the recommended steps you should take. Either you need to adjust your PID, you got to adjust your sensors, or you have to do a change to your economizer control sequence. Those are the 3 top recommended steps. So right there, you have some actions to take right out of the gate. So it really saves a lot of desk time and time in the mechanical room, troubleshooting, and potentially going to get the part to come back, right? So when we talk about a fault, a lot of the things I would also get, a lot of questions I still get, and I would get when we were doing this on the campus I was at, is why is this any different than just doing this in your building automation system, writing this as an alarm, but just adding this little nuance to it so it can kind of be like a fault. And so I'm showing you this very simple example to show that it's not so simple. So when you are looking at a fault for a zone being above or below set point, the reason this is a nice fault to have is when you're looking at a campus environment, you all know this, you have thousands of zones everywhere, and being able to track whether they're all in compliance is a very difficult task. You're really, for the most part, waiting for a comfort call. You're waiting for the occupant to be uncomfortable enough that they will call into your work control center. And so this is a nice fault to have because you can kind of see, oh, I know all of the zones that are out of compliance on my campus. I know how far they might be out of compliance, and I can go hit the big hitters. So easy. Let's look at when the zone's occupied, what's my set point, and what's my room temperature. So I say when my room air temp is higher than my set point, when I'm occupied, I want to know. Easy, right? You just take that fault, you copy it, and you paste it all over campus in all of your zones, right? No. So you probably know this too. But in my experience across campuses, depending on when the building was designed, who did the programming, who did the design, that what calling something occupied is not always the same. In some buildings, you might have an occupancy status point. In other buildings, you might just have to look and see if your VAV damper is open, and then you know it's occupied. There are different things that would indicate that your zone is occupied. And then you'd need to know in some cases whether your zone is in heating or cooling. It's not always the same point that you're looking at in the VAS system to determine that. And then what is your actual set point? Sometimes you have ranges, sometimes you have occupied heating and an occupied cooling set point, and sometimes you have the really easy effective set point, but not always. And so it becomes, when you start to copy and paste that, each time you're putting it on a new zone, you're customizing it. And then it becomes very difficult to maintain and to keep it going. So this is an important thing to ask your providers about maintenance of the fault. What is your fault detection and diagnostics program going to look like on day 1? And what is it going to look like on day 100? And how long is it going to take you to get there, right? So if you have to customize each one of your faults, it's going to take you a really long time before you have actionable information. And then if something were to change, how long is that change? How does that change management happen? How long does it take? That's an important nuance.